Our topic for today, what is a thermocouple and how it works. A thermocouple is a sensor used to measure temperature in a number of processes. Thermocouple consists of two wires made from the similar metals, which are combined together at one end, creating a junction. When temperature changes between these wires, it produces voltage as an output, which can be displayed on the multimeter. These voltages are very low in millivolts. The advantage of thermocouple is that they can detect very minor changes in temperature over a very large temperature range. It can also detect any changes in temperatures very quickly. Type K is the most common and general purpose thermocouple. Type K probes are reliable, inexpensive, and has a wide temperature range. Temperature measurement is very important and is needed in every industry. Measurement is always there, whether in the process industry, oil and gas, nuclear power plant, automotive, aircraft, and pharmaceutical. Temperature measurement is always there.
Welcome back to our YouTube channel. This is Automation Academy. If you're new here, please don't forget to like, subscribe, and hit the bell button to keep you notified and updated. Also, you can check our playlist for more videos.
The thermocouple base metals are type E, N, J, K, etc. Known are the most common categories. The material from which these thermocouples are made are inexpensive and commonly available metals such as iron, copper, nickel, etc. Below are the details of each type of base metal thermocouple. Type E thermocouple having a chromel as a positive leg and constantan as a negative leg. Chromel having a percentage of 10% nickel, while constantan has a 45% nickel. Type J, a thermocouple having iron as their positive leg, with constantan as the negative leg. Type K thermocouple having chromel as their positive leg, and the alumel as their negative leg. Alumel is having 5% nickel, and rest is silicon and aluminum. Type N thermocouple is having nitrocell as its positive leg, and nickel as its negative leg. Nitrocell is having 14% nickel and 1.5% chromium, and rest is silicon. For color code chart, refer at the chart for your reference. The temperature range in type A in degrees Celsius are 0 to 800 degrees Celsius. In type J, 0 to 750 degrees Celsius. In type K, 0 to 1100 degrees Celsius. In type N, 0 to 1100 degrees Celsius. And type R, 0 to 1600 degrees Celsius. Now, let's proceed to our thermocouple chart. In the left-hand column that I marked are the temperatures, can be either degrees Celsius or degree Fahrenheit, and it is tens or hundreds. And on the top horizontal number, from 0 to 10, are ones, for temperatures to be accurate. And on the inside value are thermoelectric voltage in millivolts. Example is 0.67 millivolts. I point the arrow towards 0.955 millivolts from 70 degree Fahrenheit. Then another vertical arrow from number 5. What is the temperature? 70 plus 5 is 75 degree Fahrenheit. And the reading of the voltmeter should be 0.955 millivolts. On this slide, we're going to discuss the standard percent error of thermocouple. For type K, the percent error is 0.75 or 2.2 degrees Celsius. If we are going to look at the conversion table, more or less 35 degree Fahrenheit. Welcome to Automation Academy TV. Our tutorial for today is what is an overload relay. Thermal overload relay is designed to protect the motor in case of phase failure or overload. The thermal overload relays does not directly shut down the load. Instead, it triggers one or several auxiliary contacts, which then disconnect the motor. An overload relay paired with magnetic contactor to form a motor starter. This is the symbol of NEMA overload relay. And this is the symbol of IEC overload relay. But before we proceed with our tutorial, let's take a look first of what is NEMA and IEC. NEMA is the largest association of electrical equipment and manufacturers in the United States. It was founded in 1926 and maintained its headquarters in Roslyn, Virginia, in Washington metropolitan area. It is approximately 350 members companies that manufacture products used in generation, transmission, and distribution. IEC stands for International Electrotechnical Commission, is an international standard organization that prepares and publishes international standard for all electrical, electronic, and related technologies known as electrotechnology. The overload header element are connected in series with a contactor to protect the motor. An overload relay also include one or more normally open and normally closed contact. These contacts are connected to pilot, buzzer, or alarm light for indication to warning the operator or maintenance. The overload relay is always part of magnetic contactor and is designed to protect the motor against prolonged overcurrent. This means if the motor is running for too long with high current, it will overheat and destroy the motor. One of the causes for this is bad bearing. Parts of overload relay: current setting. To set the current setting of the motor, you need to know the full load current times multiply it with 1.25 or 125%. Stop button, used to stop the motor. Reset button, manually reset should be done after the motor has tripped. This is the usual setup of motor control, from the bus bar going to the main disconnect. The purpose of main disconnect is to shut off the entire circuit. And for circuit breaker, designed to protect electrical circuit from short circuit and ground fault circuit interruptions. Contactor is an electrically controlled switch used for switching higher current. Overload relay designed to protect the motor from prolonged overcurrent which cause overheat and destroy the motor. And the last one is the electric motor is a machine that converts electrical energy to mechanical energy.
Hello guys, today my dad will be talking about cables and I'm just here to make the video more fun. And don't forget to subscribe and like the video.
Thanks for a nice introduction for my son Ian. Today we're going to discuss about cable and their color and sizes. A wire or cable is responsible for the main job, moving the electricity from the power plant to our homes. The conductor is located at the center of the cable. Another layer of the cable work around to protect the conductor. Let's get into it. Let's talk about cable voltage and their color. 120 to 140 volts, single phase. Ungrounded conductor, color black and red. Grounded conductor, color white. For 120 208 volts, three-phase, ungrounded conductor, the color is black, red, and blue, and the grounded conductor is white. For 120 240 volts, three-phase, ungrounded conductor, color black, orange, blue, and the grounded conductor is white. 277 480 volts, three-phase, ungrounded conductor, brown, orange, yellow. Grounded conductor, green or yellow or gray. Note, conductor with insulations that green or green with one or more yellow stripe can't be used for ungrounded or neutral conductor as per NEC 250.119. Grounded conductors for American wire gauge or larger must be identified by one of the following means by NEC 200.6b. Number 1. A continuous white outer finish along its entire length. Number 2. A continuous gray outer finish along its entire length. Number 3. 3 continuous white stripe along its length. Number 4. White or gray tape or markings at the termination. Now, let's talk about Romex or non-metallic flexible cable. This is number 14-2, 15 amperes. This is the sheeting. This is the hot conductor, color black. The ground conductor is bare cable. And the white conductor is color white. And for the 14-3, 15 amperes, the hot conductor is black and red. And the ground conductor is the same, bare cable, white conductor, color white. And the neutral conductor is color white. Number 12, gauge wire. Use general lighting and bathroom. Color yellow. 12-3 is the same. Neutral, white, ground, bare cable, hot, black. For 12-3, it's the same. The hot is black and red, neutral is white, ground is bare wire. Number 10, gauge wire. Use dryer appliance, and air conditioning. The color is orange. This is the 10-3 or 10/3. The color of the hot is black and red, and color of neutral is white. And for the ground, bare conductor. This is how we are going to connect it. For gauge number 8, wire used for feeder and large appliance. This is the same, just look here. The ground is bare cable, the hot is black and red, and the neutral is white. Number 6, used for feeder and large appliance. The hot cable is red and black. The neutral cable is white, and the ground bare cable. Number 3, gauge wire, used for service entrance and feeder wire. The same, the hot is red and black, white is neutral, and the ground is bare cable. 1/0, gauge, service entrance and feeder wire. The hot is black and red, the neutral is white, the ground is bare cable. Number 3, the 0 or /0, gauge, service entrance. We use this as a service entrance. The hot is black and red, the neutral is white, and the ground is bare cable. Please refer to wire size conversion chart, American wire gauge to square millimeters. Thank you for watching. If you like this video, please subscribe and like. Have a good one. Hello guys, today I'm going to show you how to crimp electrical connector. But first, I'm going to show you what is the name of these connectors. Here's the first one. The name of this is bullet electrical connector. The next one is fork. Next one is ring electrical connector. The next one is spade. Now, let's get started. Let's try this one. Okay. Too much. I will cut a little bit. Let's try that. I got this crimper tool at Harbor Freight. The good thing about this crimper is you have a big leverage. Before I have this crimper, but the thing is, if you are going to crimp a big terminal, so it's gonna be a little bit harder. That's why I will use this crimper. So this is an all-purpose crimper. Let's do that one and crimp. See? It's very sturdy. And we're gonna use this one here in a relay. For example, it's very good for connection. The next one, let's try this round, the ring type. We're gonna use this big electrical conductor. That's why when you are going to use this, it's very hard to crimp. There is a tendency that, you know, there is a lost contact. That's why I will not use it. So I'll use this crimper, longer crimper, so that you have enough leverage. After that, we're going to put it here. It's very sturdy, right? Next is we're going to use this spade. The spade is a male and female. First we need to look the sizes. So it's gonna be a little bit bigger. So I will try to use this one. Yeah, pretty good. Got the other end. Make another connection. Good. Usually we use this in automotive, this one in cars. The next one is the butt splice. Yeah, it's pretty good. Assuming that we're going to use this another wire. Okay. That's it, guys. If you like this video, please subscribe. If you have comments, just drop down below. Have a good one. Welcome to Automation Academy TV. In this tutorial, we will be discussing on how to disassemble and reassemble the motor so that we can check the bearing and replace it when needed. I have here an electric motor 9 leads out and sort of tools needed like bearing puller, hammer, screwdriver, prying tools, puncher, marker, socket wrench, impact driver, and a multimeter. Some motors don't have bearings on the nameplate, then you need to disassemble it to look the number on the bearing. First thing first, we make sure that the place is clean. We all have the tools and materials that needed for the job. Let's get started and help me out. First thing we're gonna do, we will make a marker on both ends of the motor. Double check. Next, we need to remove all these 4 bolts. We need to spray a little bit. So the other side has already been removed. I will use this one. We need to remove first the wire so that no one will hold the cover of the motor. Anyway, I already marked this one. When you are going to disassemble your motor, mark the terminal of the motor. We're going to take the wires. Okay, it's already removed. Remove the rotor. And sit aside and check the winding. The winding still okay. I just need to replace the bearing. The number of the bearing is 6203Z in SK. Then after that, we're going to use the puller. We already removed the bearing of the motor. Then we're going to replace it with new one. Then use the wood. Make sure that it is flush. It's not yet flush, we need a little bit more. Okay, now it's flush. Put back the stator and put the rotor in. So this is the good thing if we have marker. You see here the mark 1, 1. I put the other side 2 on the other side so that you will not get confused. Number two, we need to put back the cable. After that, we need to whack a little bit. After we whack it, we do like this. That's it, guys. If you like this video, don't forget to like, share, and subscribe. Have a good one. Welcome to Automation Academy TV. Our tutorial for today is what is the difference between a relay and a contactor. Relay and contactor same the same function by switching a circuit. If you see from the application point of view, you see a magnetic contactors placed inside an electrical cabinet, while relay used in low voltage applications such as alarms and pilot lights, etc. Both shares the same functions, electromagnetic switching, and operate under the same principle. Let's recall first magnetic induction, because without this theory, we don't have a relay, magnetic contactors, motors, generators, transformers. This principle still used most of the electrical utility today. Electromagnetic induction was discovered independently by Michael Faraday in 1831 and Joseph Henry in 1832. Faraday was the first to publish the results of his experiments in August 29, 1831. Michael Faraday was an English physicist who gave one of the most basic law of electromagnetism called Faraday's law of electromagnetic induction, while Joseph Henry was an American scientist. Relay can be used to control several circuits by just one signal. A relay contact having one or more poles, each contact energizes other circuit or stop another circuit. Protective relays can prevent equipment damage by detecting electrical faults like overcurrent, undercurrent, overloads, and reverse current. Additionally, relays are also wide use in heating equipment, pilot lights, and audible alarms. A magnetic contactor have three main contacts, line 1, line 2, line 3, or 1, 3, 5, and T1, T2, T3, or 2, 4, and 6. Have many auxiliary contacts like normally open and normally closed, used for interlocking and making other circuit. Power contactor is generally used in large amount of current to make and break large carrying load like 10 horsepower to 900 horsepower. High voltage AC contactor greater than 1000 volts may use vacuum or inert gas around the contacts and extinguishing electric arcs. Hello guys, good morning. Our topic for today is what is a relay and how it works. A relay is an electromagnetic switch operated usually by a small amount of current that can turn on or off a larger electric current. The heart of a relay is the electromagnet, a coil of wire that becomes a temporary magnet when electricity flows through it. This is a relay showing which pin is normally open or closed contact. In this example, the initial condition of the circuit while the switch number 1 is open, relay is not energized and the electric motor is not running. What will happen if we are going to close the number 1 switch? The current flows from 24-volt supply battery through number 1 switch, through number 2 magnetic coil, and energizing the magnetic relay. Once the magnetic relay energized, the number 3 single pole double through or SPDT contact change its state from 11 to 12 through 11 to 14. And the current from number 4 power voltage 230 volts flows through close contact number 5 motor, and the motor will run and the current flows back to power supply. Now let's do our practical exercise. Guys, today I'm going to show you how to wire a relay that can control a big motor. Let's do it. From the positive of our power supply, we're going to connect it here. positive of our power supply, going to our switch, going to coil of a relay A1. From A1, from A2 of the relay, going back to the negative of the power supply. Now let's try if this relay will plug in. It works. From the positive of our power supply, we're going to connect another supply, going to the normally open of our relay. From another side of the normally open of the relay, going to the coil of the magnetic contactor. From A2 of our magnetic contactor coil, going back to our negative of our power supply. In this scenario guys, I didn't plug in yet the motor, but anyway, I already connected the power circuit of the motor. When I'm going to press this one should plug in. Doesn't run yet because I didn't plug in yet the power supply. Let's try. Okay, both of them is plugged in. The relay energized and the contactor energized. Once I plug in the power source of the motor should run. Now I already plugged in the motor. Let's try if it works. It works, guys. So this is a relay, how to control a big motor using contactor and power supply. Hello everyone. Today we're going to discuss about what is magnetic contactor and how it works. A contactor is an electrically controlled switch used for switching a power circuit similar to a relay, except high rating as high as 5,000 amperes. A contactor is controlled by a circuit with a much lower current and voltage like 24 volts DC and are used in application ranging from light switch to the most complex automated industrial equipment. It is used by electrical equipment that is constantly on or off with opening and closing a circuit. Contactor has two sets of auxiliary contact. NO stands for normally open and it will close when the switch is activated. NC stands for normally closed and open when the switch is activated. A magnetic coil when energized will attract the moving core of the contactor, and the voltage of the magnetic coil usually 24 volts DC, 110 volts AC or 230 volts AC. Contactor has three main sets of contact. For supply side, line 1, line 2, line 3 or 1, 3, 5. And for the load side, going to the motor, T1, T2, T3 or 2, 4, 6. The overload relay is always part of magnetic contactor and is designed to protect the motor against prolonged overcurrent. This means if the motor is running for too long with high current, it will overheat and destroy the motor. One of the causes for this is bad bearing. Parts of overload relay: current setting. To set the current setting of the motor, you need to know the full load current times multiply it with 1.25 or 125%. Stop button, used to stop the motor. Reset button, manually reset should be done after the motor has tripped. This is the usual setup of motor control, from the bus bar going to the main disconnect. The purpose of main disconnect is to shut off the entire circuit. And for circuit breaker, designed to protect electrical circuit from short circuit and ground fault circuit interruptions. Contactor is an electrically controlled switch used for switching higher current. Overload relay designed to protect the motor from prolonged overcurrent which cause overheat and destroy the motor. And the last one is the electric motor is a machine that converts electrical energy to mechanical energy. In this example, the initial condition of the circuit while the switch number 1 is open, relay is not energized and the electric motor is not running. What will happen if we are going to close the number 1 switch? The current flows from 24-volt supply battery through number 1 switch through number 2 magnetic coil and energizing the magnetic relay. Once the magnetic relay energized, the number 3 single pole double through or SPDT contact change its state from 11 to 12 through 11 to 14. And the current from number 4 power voltage 230 volts flows through close contact number 5 motor, and the motor will run and the current flows back to power supply. Guys, today I'm going to show you how to wire a relay that can control a big motor. Let's do it. From the positive of our power supply, we're going to connect it here. Positive of our power supply, going to our switch, going to coil of a relay A1. From A2 of the relay, going back to the negative of the power supply. Now let's try if this relay will plug in. It works. From the positive of our power supply, we're going to connect another supply, going to the normally open of our relay. From another side of the normally open of the relay, going to the coil of the magnetic contactor. From A2 of our magnetic contactor coil, going back to our negative of our power supply. In this scenario, guys, I didn't plug in yet the motor, but anyway, I already connected the power circuit of the motor. When I'm going to press this one should plug in. Doesn't run yet because I didn't plug in yet the power supply. Let's try. Okay. Both of them is plugged in. The relay, energized, and the contactor, energized. Once I plug in the power source of the motor should run. Now, I already plugged in the motor. Let's try if it works. It works, guys. So this is a relay, how to control a big motor using contactor and power supply. The initial condition is we didn't start the pause button. So the current from line 1 going to our number 3 and the number 1 of the CR1. The CR1 normally close, indication for our stoplight. This one is already been light because if you're going to see here, passing from here, going here because this is normally closed, and going to line 2, it's a complete circuit. So this one should be light. And on our power circuit, it's on the terminal 1, 3, 5. If this one will close, the line current will go directly to the motor and run the motor. But at the moment, it's not yet being started. Okay, this one has already been pressed. What happened is the current from line 1 going straight to stop, to start, or overload relay going back to line 2. When this one will energize, normally open contact will close. When the time we're going to release this one, the current will pass by here. And this one also will close. So the current will pass here and the run light will on. The current from line 1, line 2, line 3 goes directly to the motor. And now the motor is running. See the indication? Okay. When we're going to stop, it will back to its initial position. To do a lockout tag out first so that we will be safe. This is our control circuit and this is our power circuit. First thing we're gonna do, I'm going to put this two auxiliary contact. You see this black dowel? I will put it here. Then need to push. Okay, that's already locked. you need to push this one, and if we are going to put it, just put it here. Anyway, this is our power circuit. I already wired the power circuit. I am marking it 1 2 3 4. See the terminal block, 1 2 3 4. From here, let's connect here. From here, going to line here, line to our control circuit breaker, going to neutral. From our 24 volts out, we are going to connect it to 1. From 24 volts, I put it to 1, so we already have supply here. The negative supply of our power supply, the negative is going to number 4. I will put it here. From 1, going to stop. Going to stop post button here. This is the stop post button. Going to start here. Then from start post button, going to our coil of our magnetic contactor, A1 here. If this is your first time here, please don't forget to subscribe and hit that notification bell so that every time I will upload a new video, you will be notified. And also, check my other video like interview question and answer, hydraulic pneumatic, FANUC robotics, motor controls, and many more. A2 is going to overload relay. Normally closed, we're going to connect it here. Normally closed. From our normally closed, going to line 4 here. So the first rung is already complete. What we're going to do now, we're going to test if this magnetic contactor will pull in. Turn it on. Turn on the main circuit breaker. Turn on the control circuit breaker. See, we have the lights, so it's on. So the motor is already running, but we don't have latching because we didn't connect this auxiliary contact normally open. Now let's connect this one. Let's just off the control voltage. 1 of the start, we connect it here. Then, so normally open is here. Connect it to the other end of the normally open contact. We need to switch on the control voltage. See? In order to stop it, we need to press the stop button. From normally open, going to our lights. Okay. Going to our lights here. From our lights, line 2 of the lights going to number 4. So this is the good thing if we put the numbering system in our wiring diagram or our schematic diagram, we will not get lost. Let's try again. We're going to start this one. This one is light, so I'm going to switch it off. The next thing we're going to do, we're going to connect this one so that this one will light when the motor is not running. It's just an indication. Let's connect to line 1. Number 1 here. Going to our normally close. And after that, let's connect to stop lights. Then from stop, out of the stop, number 2 of the stop, we're going to connect to line 4 here. Okay. Now we're going to start. Stop. This one should lit. Okay, good. When the pause button is pressed, the current flows from line 1 through stop 1, stop 2 that is connected in series, through start button that is connected in parallel, through magnetic coil, CR, through overload relay contact, and on line 2. This energizes control relay, which when energized closes the normally open contact to establish the holding circuit for the control relay. When the start button release also closes the control relay main contact to line 1, line 2, line 3 and complete the circuit to run the motor. Closes also the normally open contact for the run light indication and open the normally closed contact for stop indication. Pushing either of the two stop pause button will open the circuit to the magnetic coil and the magnetic coil de-energize. Today I'm going to show you how to wire multiple start-stop circuit. Let's get started. From the positive terminal of our power supply going to line 1. For the negative supply for our 24 volts going to line 4. So now we already have supply from our 24 volts power supply going to our terminal block. So this one. From line 1 going to our stop pause button here. Out of the stop pause button going to remote stop pause button. The remote stop pause button is here. I already wire for the stop 1 and 2, for the start 3 and 4. So I will going to connect to 1. I will just use wire nut to join it. From our 2 going to our start button is going here. Put the wire nut again. Going to our start button. From our start button going to our A1 of our relay of the magnetic contactor. Up A2 is going to overload relay. Overload relay normally close here. NC. And from NC going to line 4. Going to here. Now we're going to try if it works because it's already complete circuit. From line 1 going to line 2 for the first rung. Let's try to start if this motor will run. Okay, it's run, but we don't have yet a latching circuit. And for the other start button, you are going to connect to 4. Okay, now let's try if it will start here. Okay, this one is already done. What we need is, we just need a auxiliary contact, the latching contact. This is normally open. Okay, we still need one here, going to normally open of our magnetic contactor. Open is here. This time, it should latch. When you are going to push it here, the start button, you can press here the stop button. That is multiple start stop. If I'm going to press the start here, I can stop it here. So even though when you are 100 feet away, you can still start. See this one? You go to the other location, stop it. Now the next one is we're going to connect the indication light. From line 1, going to the normally open. From normally open, going to our lights. Start. And from lights, going to line 4 here. When I'm going to start, this indication light for run button should light. Okay, when we're going to stop, it should stop. It should go away. Okay. Next is we're going to connect normally close for our stop indication light. From line 1, going to our normally close. From our normally close, going to lights. Lights. From our tube lights, going to 4. Tube lights going to 4. Here. Okay, when I'm going to start, this one should go away. When I'm going to stop, start, stop. Jogging is the process that uses quick power in order to move a motor or load like conveyor into a desired position. According to NEMA, National Electrical Manufacturers Association, jogging is a quick repeated closure of a circuit to start a motor from stop motion for the purpose of accomplishing a small movement of the driven machine. Let's get started. When you press the start button, the current flows from line 1, goes through the stop pause button that is connected in series with the circuit, through the start pause button that is connected in parallel, through the magnetic contactor, overload relay, then back to the power supply line 2. When the magnetic contactor is energized, the normally open contact, which is our latching or sealing contact, will close. When you release the start button, the current flow will divert from line 1 through stop pause button, through normally closed auxiliary contact, through normally closed jog contact, through the magnetic coil, overload relay, then back to line 2. When you are going to press the jog pause button, the current will flow from line 1 through stop pause button, through the normally pause button that held closed momentarily, through the magnetic contactor, overload relay, then back to line 2. Thank you for watching and see you on the next video. If you like this video, please like, share, and subscribe. Have a good one.